Let's look at the piece of paper that looks like this first. So it's that piece of paper with a bunch of different sections, front and back, all that loveliness. All right. So technically, you guys already know parts of the unit circle already because we talked about it when we were doing conversions between degrees and radians. All right. So you already know part of the unit circle already. The new part is going to be the actual points. So the unit circle, the thing about a unit circle is that there are actually points on a coordinate plane that fit to go with these different parts of the circle. All right. So what is the unit circle? The unit circle is a circle where the center is at the origin and it has a radius of 1. So 1 unit on either side. All right. So what that means is that if I am looking at this unit circle up here, all right, so this is actually a unit circle. All right. If this is the origin and it's 1 away, what's this point? 1 what?
1 point.
So guys, this is the origin. So think coordinate plane. This is the origin. This is 1 away from the origin. This is 1, 0. 1 away.
0,
0, 1. 1 away.
-1, 0.
1 away.
-1.
So you already know 4 points of the unit circle now. Unfortunately, it's not that easy. All right. So these are like the 4 base points. So all 4 cardinal directions are exactly 1 away. That's how long the radii is. All right. So every radius going from the origin to the edge of the circle is equal to 1. All right. Now, that being said, with the unit circle, it's broken up into different fractions of the pieces itself. So basically, if we're talking quadrants, quadrant 1, 2, 3, 4, these are broken up into different fractional size pieces. Typically, the unit circle is broken down into halves, thirds, fourths, and sixths. All right. Now, that's typically the type of fractions that we're going to be using, and you'll see that when we do the radian side of it. All right. Now, in the unit circle, it's made up of angle degrees, radian measures, and coordinates. All right. So each one of those dots on that circle is a coordinate. All right. So the first thing we're going to do, yes. Yeah. So the first thing that we're going to do is that we're just going to review the degrees and the radians because we technically already know this. All right. So on the front of this paper, let's start with degrees because that's the easiest. So do you guys remember last week when we did radians to degrees and they gave us a circle that had like all these measures all the way around it, and we did it based off of that. That's kind of what we're doing here. So when I talk halves, fourths, thirds, and sixths, I'm talking about in terms of a semicircle. So it's almost like there's an imaginary line right here. Because just like when we were doing radians to degrees and vice versa, it was always in terms of 180. So think back. Right here, let's say this is 0 degrees. This is also known as what? So if we start here and we go a full rotation around the circle, what is this also? 360. Now, if we go half a rotation, so right here, what would this be? 180. So the way the unit circle works is that you always start at 1, 0, or on the x-axis on the positive side of the x-axis. All right, so on the right side of the circle, that's where you start. That's 0 degrees. Full rotation is 360. And you're always rotating counterclockwise. All right, you always rotate this counterclockwise. Now, if I go from 0 and I go a fourth of the way around, what's a fourth of 360? 90. All right, if I go another fourth, that'll be 180. And then what's another fourth of 360? So 3/4 of 360. 270. All right. Now let's figure out the eighths parts or fourths. So if I go an eighth of the way, so what do you think would go right here? Halfway between 90 and 0. 45. What about halfway between 90 and 80? 180, sorry. So it's 3/4 of the way from 0. So what's 3/4 of 180? It would be 125, yes. All right. What about if we go another fourth? All right, so now we're 5/4 away. So 180 is 4/4. Now we're 5/4 away. What's 5/4 of 180? You guys may want to put this in your calculator. So 5/4 of 180. To what? 225, right? Correct me if I'm wrong. Yes.
3/4 of 180 is 135.
Yeah, that's what I thought. It's like, okay, no, that's it's 130. All right, yeah. So 135, 180. The next one is what? 225.
315.
Then you add another one, 270, and then another. So we're 7/4 of the way from 180. Not 325, it's 315. So does anyone know the pattern here? So if I go from 0 to 45, I add 45. 45 to 90, I do what? Add 45. 90 to 135, what do I do? Add 45. So if you notice, between all of these, we're adding 45. So that's the pattern here. Add 45 degrees. 4/4. All right. So that's the part of the unit circle that's in fourths. Now we're going to look at it in terms of sixths and thirds. So this one right here is 6 dash thirds. Because remember, the 6 can simplify down to thirds. All right. So we're going to start in the exact same spot. So we start at 0, and this will also be 360 degrees. Over here is still going to be 180. 90 is still going to be up here. 270 are still going to be down here. Those four are constant. All right, so the four cardinal planes. East would be 0, 360. North would be 90. West would be 180. South would be 270, always. So the four cardinal directions, that's how they always go. Now, if I want to go 1/6 up, so again, we're still rotating counterclockwise. That's always a given. We're always going to rotate counterclockwise from our starting position, which is 0. Now remember, we're always doing this in terms of 180. What is 1/6 of 180? 30. So this first one right here, 1/6 away is 30 degrees. What's 2/6 or 1/3? 60. 3/6 or 1/2 is 90. What about 4/6 or 2/3? 120. What about 5/6? Nope. 150. All right. And then 6/6 is 180. What about 7/6? 210. All right. What about 8/6 or 4/3? 240. 9/6 is 3/2, so that's 270. What about 10/6 or 5/3? 300. Then this last one will be what? 330. So what's the pattern here? Plus 30. So for 6, we're looking at plus 30. Now, let's look at the thirds. So the thirds are right here. So where I drew those blue lines, these are all the thirds. All right. And that includes the 180 and the 360. So this is also a third, also a third. So what is the pattern for the thirds? So my first third starts where? From 0. So where does my first blue line go from 0? 60. Where's my next one? 120. Where's my next one? 180. Where's my next one? 240. Next one? 300. All right. So what's the pattern here? We add what? 60. So thirds, we add 60 degrees. 6, we add 30. Now, we essentially just came up with all of the degrees for our unit circle. So now we're going to put these two circles together. All right, so this would be a unit circle right here. So we can go ahead and mark 0 degrees, 360 degrees. We can go ahead and mark 180 degrees. And we always know that half the way to 180 is 90. 3/2 of the way from 180 is 270 degrees. All right. So let's talk fractions. What is the smallest fraction between the three that we talked about? A fourth, a sixth, or a third? Which one's the smallest? A sixth is the smallest. All right, so if a 6 is the smallest, that means my first line away from here is 1/6. So this is 1/6 away. So if that's the case, what's my degree if it's 1/6 away? So we're still going around. So 1/6 away is what? 30 degrees. Now, what's the next smallest? 1/4 or 1/3? 1/4. All right. So if we have 1/4, what's my first fourth away from 0? 45 degrees. Now, that leaves a third. So what's my first third away from 0? 60 degrees. And then we get to our half right here. You guys see the pattern? So that's how we're putting it together. Now, we're then going another 6 away from 90 degrees. So 3/6 plus 1/6 is 4/6, which simplifies down to what? What does 4/6 simplify down to? 2/3. So what is 2/3 of the way from 0? 120. We then have another fourth. All right. So this would be 135 degrees or 3/4 of the way. All right. Now we're at 5/6 of the way, which is what? 150 degrees. So now we're at 180. We're going to go another 6. All right, because that is our smallest one. So 6 over 6 is 180. So we can label this as 6 over 6, 2 over 2, or just 1. All right. But I'm just going to label it as like 2 over 2, or however you want to put it. So 6 over 6, 2 over 2, however you want to put it. That means if we go another 6 away, we're at what? So 6 over 6 plus one more 6 is what? 220. So 7/6 of the way is what I was looking for. But that's 220 degrees. Yes.
How is that 220?
Not 220. I read it wrong. 200.
Not 210?
That's what I meant. No. I hear things and that's what I think. Okay. So I heard 220. I went with it. That's not correct though. So it's 210. Now, another fourth away from 180. So 4 over 4 plus another fourth is what? 5/4. 225 degrees. Now, a third of the way, because if you notice the pattern, it's always going third, fourth, sixth, sixth, fourth, third. So now we're at the thirds. So a third of a way from 3 over 3 is what? 4/3. If you add another third to 3 over 3, you get 4/3. And that would be what as a degree? What's a third away from 180? 240. Then we're back at 3/2. All right. Now, so we're going another 6 away from 6 over, not 6 over, from 9 over 6. So that's 10 over 6, which simplifies down to what? 5/3. So it's 5/3 away. 300. So 5/3 or 1/6 away. You can do it either way. Now we're a fourth of the way. So that's 7/4 because this is 6/4 plus another fourth is 7/4. So what's that? 315. And then lastly, we're at 11/6. So that would be 330. Now those are the degrees for all of for the unit circle. All right. So the reason I had you guys do the fractions is because that's what's going to come in handy when we do the radians. All right. So now flip over to the back side of that paper. We're going to do the same thing, but with radians. So we're going to start with fourths. All right. Now, let's go about what we already know. So if we start with fourths and halves, if we start at 0, what's a full rotation in radians? So what's 360 as a full rotation in radians? 2 pi. So we know we're going to end with 2 pi. Now, 180 degrees is still going to be on the left side, but what's that in radians? Pi. So now think about this in fourths. What is 1/4 away from 0? Or a fourth of pi? Pi over 4. So we're doing all of this in terms of pi. So fourth away from pi is pi over 4. What's another fourth away from pi? So 2/4 away from pi. So what's 2/4? So if we go another fourth, what's 2/4 away from pi? 2 pi over 4, which simplifies down to what? 1/2, or throw a pi in there. Pi over 2. So that comes from 2 pi over 4. You just simplify the 2 and the 4. And you keep the pi where it is. What's another half away? Not half. What's another fourth away? So we just got 2 pi over 4. 3 pi over 4. Now, pi is 4 pi over 4, obviously. Or 2 pi over 2, however you want to put it. So, what's another fourth away from pi? So it's another fourth away from pi. So if we have 4 pi over 4 and we add a fourth to it, 5 pi over 4. We're literally just adding one to the numerator, y'all, and just simplifying where needed. Add another fourth. What do we got? 6 pi over 4, which simplifies down to 3 pi over 2. And then lastly, another fourth away is what? 7 pi over 4. And then this one would also be 8 pi over 4 if you wanted to finish the rotation. So the radians for your fourths is these two, this, so all of these, the simplified version. So whenever you do the unit circle, we want the simplified versions of the radians. So this is the fourths. And again, basically all you gotta do is add a fourth. That's all you gotta do. So the fourths, you just add a fourth to the numerator. Does that make sense? How we went around. All right. Now let's look at the 6 and thirds. So we're going to look at specifically in terms of 6, but you'll see where the thirds come in. So, same starting points. All right. So, same starting points. We still got 0 and 2 pi over here. We still got pi over here. All right. So, now we're just going 1/6. So, what's 1/6 of pi? So we're writing this in terms of pi. Pi over 6. So 1/6 of pi is just pi over 6. If I go another 6, what do I get? So I add another 6. What do I get? It'll be 2 pi over 6 or pi over 3. Add another 6. What do I get? 3 pi over 6, obviously, which simplifies down to pi over 2. Add another 6. What do I got? 4 pi over 6, which simplifies down to 2/3 or 2 pi over 3. Add another 6. What do I got? So it's one more than 4. 5 pi over 6. Add another 6. This will be 6 pi over 6, which is pi. Add another 6. What you got? 7 pi over 6. Add another. What do you got? 8 pi over 6, which simplifies down to what number can you divide both 8 and 6 by? 2. So if you divide both by 2, what are you left with? 4 pi over 3. One more pi, or one more 6 over. What do I got? 9 pi over 6, which simplifies down to 3 pi over 2. Add another 6. What do I got? 10 pi over 6, which simplifies down to 5 over pi over 3. Then one more 6. What is it? 11 pi over 6. And 2 pi, if you've got to have that completion, is 12 pi over 6. So what you care about are all my simplified versions. Now, if you notice y'all's thirds, so again, the thirds are in the same spot as they were the degrees. So right here. If you go 1/3 away from 0, it's pi over 3. Another third's 2 pi over 3. Another third is 3 pi over 3, or pi. Another third is 4 pi over 3. Another third is 5 pi over 3. And another third is 6 pi over 3, or 2 pi. All right, so that's where the thirds come into play. Now, let's throw it all together. All right, so let's already mark what we know to be true. So what has to go right here? What has to go right there? So what has to go right here? 0 and 2 pi. All right, now, what fraction do we say is the smallest? 6th, third, or fourth? A sixth. So if I go 1/6 away, what do I get? So if I'm 1/6 away, what? It's pi over 6. All right, because remember, right here is what? Pi. All right. So whenever you label a unit circle, always start with 0, 2 pi, and pi. All right. Those are like the easiest ones to remember. Now, what's the next biggest? 4th, third, or half? A fourth is the next smallest. So what's 1/4 away from 0 in terms of pi? Pi over 4. What's bigger than a third or a half? Or smaller, I mean. So what's smaller, third or a half? A third. So it's a third of the way from 0. Pi over 3. Then finally we have a half, which is pi over 2. All right. Now, if you remember this part right here, the rest of it follows a similar pattern. All right. Because what do you think my next one is? So we know it's going to be adding a sixth of some sort, but is it going to be actually a sixth or a third? It's going to be a third. What is that third? 2 pi over 3. So you could think about it as 4 pi over 6, but you got to simplify to 2 pi over 3. Then if we go another fourth away, what is it? 3 pi over 4. We go another 6 away. What is it? 5 pi over 6. And that half would be pi. Yes. After we finish this. Just this part, yeah. All right. Now, we're now going another 6th of the way. So it'll be another 6 away from pi. 7 pi over 6. Then we're going a fourth of the way. 5 pi over 4. Another third. 4 pi over 3. Another half. 3 pi over 2. So now we got another third. Five pi over 3. Another fourth. 7 pi over 4. And lastly, another 6. 11 pi over 6. And those are all your radian measures. So if you notice, it always goes half, 6, fourth, third, half, and then it flips. So third, fourth, 6, half, flips again. 6, fourth, third, half, flips. third, fourth, sixth. So the fourth is always the one in the middle. It's between two halves, and then the third and the sixth switch each time. But if you remember that first quadrant, it's easy. And just remember where your thirds are. Where your halves are. Your fourths. And your sixths. All right. So your six would also fall in line with your blue lines. Your fourths would fall in line with your red lines as well. All right. So here's what we're going to do. We're going to take our 5-minute break. We're going to come back and do some notes in your packet. So now we're going to figure out the actual coordinates. All right. So be back in here by 12:10. So guys, if you're still in here, have page 5 open in your packet. So if you guys are in here, page 5 of your packet, have that ready to go. Shut the phone up. So you guys have page 5, open your packet, ready to go. All right, guys, so I'm on page 5 of your packet. So we've done the radians of the unit circle, we've done the degrees of the unit circle. Now we're going to do the ordered pairs of the unit circle. Now, this is where you got to know your right triangle properties. All right. So a unit circle, a basis of trigonometry is a very special circle known as the unit circle. It's simply a circle that has a center located at the origin and a radius equal to 1 unit. All right, that's why they call it the unit circle, because the radii is all 1 unit. So this is this is review from our last unit. If it has a center at the origin, meaning the center is at 0, 0, and it has a radius equal to 1, what's the circle equation? So remember, circle equation is x minus h all squared plus y minus k all squared is equal to r squared, if h and k is the center. So which of these options here do you think is my circle equation for the unit circle? What do you guys think? 4. Not 4. That would mean it has a center of 1, 1. I want a center of 0, 0. It's 3. Because since it has a center of 0, 0, x minus 0 is just x squared, it's x squared. Y minus 0 is y squared, it's y squared. And then 1 squared is just 1. Now, we got to seek to produce some of the coordinate points that lie on the unit circle through the use of the Pythagorean theorem. So these next 2 exercises, we're going to kind of figure it out. All right. So consider the right triangle shown whose hypotenuse is equal to 1 and the angles are both 45. Since they are isosceles triangles, that means 2 equal sides are labeled x, and we're going to solve for x and place our answer in the simplest radical form. So we're going to use Pythagorean theorem here. So we're going to use a squared plus b squared is equal to c squared. So remember, a and b are your legs, c is your hypotenuse. So if I put this in the formula, I would get x squared plus x squared is equal to 1 squared. So if I simplify, what's x squared plus x squared? Could I combine those like terms? Yes, I could. So this could be 2x squared is equal to what? Just 1. All right. Now I need to solve for x squared. So what do I need to do first? I'm solving x for x squared. So to get x squared by itself, I need to do what? Divide by 2. So I get x squared is equal to 1/2. Then I take a square root of both sides. Now, remember, the square root of 1/2 is the exact same thing as x is equal to the square root of 1 over the square root of 2. You can break it up. What's the square root of 1? 1. And we don't know what the square root of 2 is. Now, this is a review from Math 2. If you have a radical in the denominator, what do we have to do? Does anyone remember what the word's called? So we have to do what we call rationalize the denominator, meaning we cannot have a square root in the denominator. It's just bad ethics in mathematics. You just don't want it. So we got to multiply to get rid of it, the top and the bottom, by the square root of 2. So we're going to multiply the numerator and the denominator by the square root of 2 over the square root of 2. So 1 times square root of 2 is obviously square root of 2. If I multiply the square root of 2 times the square root of 2, what do I get? So think about it. That's the same thing as square root of 2 squared, right? What's the square root of 2 squared? Just 2. So square root of 2 times the square root of 2 is the exact same thing as the square root of 2 all squared, which means that these cancel out and I'm left with 2. So this x is equal to square root of 2 over 2. So this would be square root of 2 over 2. This is square root of 2 over 2. All right, those are my two side lengths. You could have also figured that out given that it's a special right triangle, specifically of the 45, 45, 90 variety. Meaning that if you have x and x, 1 would be equal to the same thing as x times the square root of 2. So because it works out that way, because if we multiply, so let's say we have x and x, and then the other side would be x multiplied by the square root of 2. If we multiply the square root of 2 over 2 by square root of 2, we would get 2 over 2, which is what? 1. So it works. All right. Now, you may be wondering, why the heck do I care about this? You'll see in a second. So just go with the flow right now. You'll see why I'm doing this in a second. All right. Now, consider the 30, 60, 90 right triangle shown below. The hypotenuse is equal to 1. Clearly, the triangle is half of an equilateral triangle. So, if it's half of an equilateral triangle, that means that if I drew another half over here, all of these sides would be equal to 1. All right? Because this would be another 30-degree angle because it needs to add up to all sides being 60. So that means that my shorter leg right here would be equal to what? If it's half of an equilateral triangle. So think about it. If I drew on this extra triangle and this total side length is 1, and we know for a fact that this triangle is exactly half of this big triangle, what's half of 1? 1/2. So the length of the shorter side is a half. Now we got enough information to do the Pythagorean theorem to find the other side. So let's call this other side for right now x. So I'm going to do 1/2 all squared plus x squared equals 1 squared. So what's 1/2 squared? So that's the same thing as 1 squared over 2 squared. What's that? What's 1 squared? What's 2 squared? 4. So 1/4. Another way to think about it is 1/2 times 1/2. Plus x squared is equal to just 1. So I then subtract the 1/4 over to the other side. which if I take away a fourth from 1, what do I end up with? So think about it. If you had 4 fourths and you took away 1 fourth, what are you left with? 3 fourths. So I got x squared is equal to 3 over 4. Then I got square rooted again. And remember, this is the same thing as x is equal to the square root of 3 over the square root of 4. Now, square root of 3 we can't simplify, but what's the square root of 4? 2. So x is equal to the square root of 3 over 2. And since we don't have a radical in the denominator, we're done. So x would equal over here square root of 3 over 2. Now, we could have also figured that out using the special right triangle of the 30, 60, 90 variety, which states that our short leg, which is the 1/2, if it was A, or we can call it X, however you want to put it, to get to the long leg, we would just do X times square root of 3. So this would be X times the square root of 3, which 1/2 times the square root of 3 is, in fact, square root of 3 over 2. And then to get to the hypotenuse from the short leg, we would just multiply the short leg by 2, which 1/2 times 2 is, in fact, 1. All right. So the biggest thing that you guys need to remember from both of these are these numbers right here. All of these numbers you need to remember. And you'll see why in a second. Because now we can figure out the coordinates of our special right triangle. We technically already have them. So we go to our unit circle. All right. The unit circle is made up of 30, 60, 90 triangle. Is made up of special right triangles. So it's made up of 30, 60, 90 triangles, and it's made up of 45, 45, 90 triangles. So what we're going to do is that we're going to figure out what all of these triangles are. So first things first, what we're going to do. We're going to start right here. All right. So if I start right here, so if I'm doing a vertical to a horizontal, what's this angle? So the vertical and the horizontal line are intersecting. That means the angle is 90 degrees. So this is where the 90-degree angle is. Now, how far away do we say that this triangle is from 0? So if I want the measure of this angle right here, how far away is that from 0? It went whoop. So it's 30 degrees away. So this little angle right here is 30. Thus, by process of elimination, that top angle right here is what? 60, right? 30 plus 60 is 90, plus another 90 is 180. Now, we know that the radii of a unit circle is what? So the radius of the unit circle is what? The radius of a unit circle is always 1. Remember, because if we go 1 this way, so it's 1 away. That's true for any radii. All right. So we know that the radii is 1. So would it be one of the legs or the hypotenuse that's equal to 1? The hypotenuse right here. That's the radii, that'll be 1. You guys seeing it yet? Did we already do this? So if this is 1, what does the short leg have to be? Look back at what we just did. What side length was directly across from the 30-degree angle? Landon. Directly across from the 30-degree angle. So diagonal from the 30-degree. 1/2. So this over here is 1/2, which means the other side has to be what? So directly across from the 60-degree angle. Square root 3/2. Now, here's why this is important. We now have all the information we need to get the point where we're 30 degrees away from the x-axis. So if we're talking about a point xy, x refers to what specifically? When we think x values on a coordinate plane, what do you think? Horizontal. So in other words, the horizontal distance. What's my horizontal distance here? So if I'm going from the origin horizontally, what's this length here? Square root 3/2. Thus, my x value of this point is square root of 3/2. Because that is my horizontal distance. So this is equal to x. Now, when you think y value, you think what? Or y-axis. What do you think? Vertical. What's my vertical distance? How far up did I go? 1/2. Thus, my y value of this point is what? 1/2. Thusly, we got our first point. Now we're going to do it again, but with 45 degrees. All right. So this is where you might want a different color. So I'm going to draw my 45-degree triangle. So 90 degrees is right here. Still a radius of 1. This angle is now 45 degrees, which means this angle is also 45 degrees. Thus, we're using what type of special right triangle here in the blue? It's a 45, 45, 90. So we're using which one? The first one that we did or the second one that we did? The first one. Thus, without even having to think about it, what are these two side lengths? We already found them. Yep, square root of 2/2 for both. All right. Now, same process. What do you think my point is? Using the same process that we did for the previous one. So what's my horizontal distance for the blue triangle? How long is the horizontal line of the blue triangle? Square root 2/2. So that's my x. What's my y? Square root 2/2. That's my vertical distance. So the length of my vertical line. You guys see the pattern? All right. Now, the last one. So this one right here. So this is the right angle. This big angle right here is 60 degrees. This little angle is 30. So, oh crap. So, and obviously the radius is 1, so the hypotenuse is still 1. So, given what we know, the 30, 60, 90 triangle, but instead of it being flipped like the red one, it's turned backwards. So, what would be, if I'm using my 30, 60, 90 triangle with a hypotenuse of 1, so the second one we did, what's the measure directly across the 30-degree angle? So the horizontal line right here. 1/2. So right here, this will be 1/2. What about the vertical? What would that be? Square root 3 over 2. Thus, what do you think my point would be? Backwards. 1/2 square root of 2, because your x value is always your horizontal length, the y value is your vertical length. And then guess what? The rest of the way around, it repeats. All right. So if you know these 3-point configurations, you got the rest of them. You just have to fit the signs to fit the origin. So if this is the first origin, all the points are positive. What's going to happen here? Which one's going to be negative? The x value is going to be negative. What about here? Both are negative. What about here? Just the y are negative. All right. So we still got our other points, like I said. So this will be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So let's figure out the rest of the points all the way around. All right. So think about what type of triangle you would draw here. So if I drew a triangle right here at 120, what type of angle would be right here? Or what type of angle would be right here specifically? So from 180 to 120, how many degrees is that? 60. So that means it would match which triangle over here? The green, the blue, or the red? The green. So what configuration point do you think I'm going to have? Right, so it'd be negative 1/2. Oops. So this would be negative 1/2 square root 3 over 2. Because if we look, if we think about it, this right triangle is 60 degrees. 120 is 60 degrees away from 180. Thus, the 30, 60, 90 triangle where the 60 degree is at the origin. So we use the same thing as the green triangle. What about from 135 to 180? How far away is that? 45 degrees. So, which triangle over here do you think we're going to use? The blue. So what do you think the new point's going to be? Right. So this is the blue triangle. So we take whatever the point is at the blue triangle and then just change the sign to fit the quadrant. So it'd be negative square root 2 over 2, positive square root 2 over 2. And how far away is 150 from 180? 30 degrees. So we use the red triangle. So if I do that, that means my new point would be what? Right. So it would be negative square root 3 over 2 and 1/2. So let's just finish the rest of this quickly. How far away is 210 from 180? 30 degrees. So we're going to use what color triangle? The red. So if it's 30 degrees away, all right, that means that this point will be what if we make it to fit the origin? Negative square root 3 over 2 and negative 1/2. What about 225? How far away is that from 180? It's 45 degrees. So this would be negative square root 2 over 2, negative square root of 2 over 2. Then lastly, this is 60 degrees away. So this would be negative 1/2, negative square root 3 over 2. Now, how far away is 300 from 360? 60 degrees. So this would be 1/2 is positive, and then negative square root 3 over 2. 315 is 45 degrees away from 360, so this would be square root 2 over 2, negative square root 2 over 2. And lastly, 330 is 30 degrees away from 360, so this would be square root 3 over 2, negative 1/2. And just like that, guys, you got all of your coordinates for the unit circle. Now, very last thing, and then I promise we're done. We just got to put it all together in one big unit circle. All right. So we're taking everything that we already learned and we're just going to throw it together in one unit circle. All right. So the radians, the degrees, and the coordinates. I told y'all it's a pain. Now, do you guys also see the pattern that's going on here? So if you notice, if you remember, you really only have to remember because I will be quizzing you every day on this unit circle and I will time you on it. You'll get 5 minutes for your first attempt, which will be tomorrow. If you remember the first quadrant, the rest of it's easy. Because if you notice the pattern, it's like 1, square root 3 over 2, 1/2, square root 2 over 2, square root 2 over 2, 1/2, square root 3 over 2. Then, once you get to 90, which is 1, 0, 1, you switch the order. So it's like you're going up, now you're going back down. All right, so you start with what you started with on the other side, which is the 1/2. But you just got to change it to fit the quadrant. So since the x's have to be negative in quadrant 2, you just make the x negative. Then you go back down. Then you're going back up again. So square root 3 over 2. But you got to make both negative now because it's in quadrant 3. Keep going around. Then you're going back down again. So now you're at 1/2, but the y value has to be negative. Does that make sense? All right. I'm just giving you guys tips to figure it out. All right. So take that yellow sheet with the full unit circle on it, and we're just going to fill it in very quickly together. So here's my suggestion to you guys while you're practicing the unit circle. All right. I printed off like 100 copies of the unit circle front and back, blank. My suggestion to you is the more you write it down, the better you'll get at it. So the more you just copy it, the better you'll remember it. So my suggestion to you is take a couple of those yellow sheets up front and just keep copying them. All right. That's the best way to practice it. All right. Because at some point it'll become muscle memory. I can fill out a unit circle because I've been doing it for so long. I can finish it in 2 minutes. All right. I don't expect you guys to do it in 2 minutes. I do expect you to do it in 5. Oh, we're timing. I mean, sure, but I'm not going to do it on my computer, but I'll do it after this. You can time me. All right. So if we're looking at our blank unit circle, we're just going to put everything together. So my suggestion to you is do the degrees first. It's always the easiest. All right. So you're always going to start in the left corner. So this will be 0, 360. All right. Now, the next one around is 30, 45, 60. Then we have 90, 120, 135, 150, 180. All right, so we're just taking what we did on our separate sheet of paper earlier with the degrees and we're just copying it in. Then we have 210, 225, 240, 270, 300, 315, 330. Then it ends at 360. So those are all of our degrees. All right. Then I would do the radians. So again, start in the horizontal right side. This is still 0. This will be 2 pi. And then think about your fractions. So you always start with the 6, then you go to the fourths, the thirds, and then the halves. So this would be pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. All right. Then it would be 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. And that's all your radians. Then finally, you would do your coordinates. So I would start by just labeling your ones that are between zeros and ones. All right. So this will be 1, 0, 0, 1, negative 1, 0, 0, negative 1. And if you think about it, horizontal distances, guys. So it's always going to be 1 away from the origin. So if you're on the x-axis or the horizontal, 1 away to the right is 1, 0. 1 away to the left is negative 1, 0. It's the same thing for the vertical with the y-axis. Then square root 3 over 2, 1/2. Square root 2 over 2, square root 2 over 2, 1/2. Square root 3 over 2. Then we have negative 1/2. Square root 3 over 2, negative square root 2 over 2, square root 2 over 2, negative square root 3 over 2, 1/2. So guys, again, we're just taking all the stuff that we did separately and just putting it all into one big circle. Then after negative 1, 0, we have square root 3 over 2, and it's negative, negative 1/2, negative square root 2 over 2, negative square root 2 over 2, negative 1/2, negative square root 3 over 2, 0, negative 1, and then 1/2, negative square root 3 over 2, square root 2 over 2, negative square root 2 over 2, and then square root 3 over 2, negative 1/2. And thus you have the unit circle. So with your unit circle quizzes, I'm going to take your best score. You're going to get it up until the day of the test. All right. It's going to be from memory. All right. So again, it's going to be a blank unit circle just like what's on the yellow sheet. That's what you're going to be given. You have to fill it out in its entirety correctly. The more you memorize this, because you don't get this on the EOC, but you can bet your butt you're going to have questions about it. So you need to know this. That's why I'm making you do these quizzes, because it's going to force you to memorize it. All right. My kids from last semester, when I did this with them, with all those quizzes, it forced them to memorize it. I had almost all my kids have 100% accuracy on the unit circle by their last attempt, guys. So if you make 100 on your first attempt or on your second, you don't have to do it again. The goal is to get 100. All right. So your goal is to get 100, but I will take your highest score. All right. Now, here's what I want you to do. There is a delta math on this. All right. So you guys got a little bit of time before the bell rings, but your exit ticket today is to fill out. Well, no, it's not. But what I want you guys to do is hold on to that. But I also want you, there's a backside to it. Fill out another unit circle, just for the heck of it. All right. If you need the reference, so you don't have to keep flipping the paper, it's right here in your journal entry. All right. Also, for the journal entry, go through and write in the radians and then write in the ordered pairs. All right. That's what you have to do on your own for your journal entry. All right. But your unit circle's right here. So my suggestion to you right now, flip it over on the back side, write in the unit circle from memory. Yes. Yes. And again, still, yes. What point? So what coordinate? So guys, my suggestion to you, take a couple of these. I got plenty. Take a handful and just fill them in. Do some from memory and time yourself. I will time you 5 minutes for the first one. All right. Now, just for the fun of it, do you guys want to time me? See how long it takes me? All right. I'll let y'all use one of your phones so you know it's a fair time. And for even more, I will do it in 10. All right. Tell me when to go. 2 minutes. Wait, no, just start a timer. Not a timer. Start a stopwatch.
Ready? Go.
Done. You guys want to check me? So it's doable if you know it backwards and forwards. And again, you know how I did this? I wrote it 20 billion times. That's how I've memorized that. So again, I better see a bunch of you take some of these yellow sheets home with you. Anyone want a freebie Miss Murphy filled out unit circle? Oh crap, Mariana. I don't think you have time to finish. Do you want to finish tomorrow? Sorry,
There's a
listen.
world record for the fastest unit circle.
What is it?
The world record is 1 minute and 18 seconds in Boston in 2004. And then a woman's world record is 1 minute and 34 seconds.
I'm pretty freaking close.
Like, yeah, I'm 20 minutes long. 20 minutes long.
Rosa, do you have your journal with you? Okay, I'll take it real quick. Let me grade it super quick. Oh, Vanessa, I think I already graded your journal. It has a grade on it. I looked at it. It has a grade on it. I guess I looked. I think I remember why. You gave it to me like on the day of the test because you were here on the day of the test, but you just didn't take the test. So I think that's what happened. Rosa, come here.